Evaluating machine learning models, why it matters. Imagine training a dog. You wouldn't just teach it tricks and hope for the best, right? You'd want to know how well it's learning. Model evaluation is like testing your dog's progress. It helps you understand how well your machine learning model has learned from the data. This is crucial because a poorly performing model can lead to inaccurate predictions and unreliable results. By evaluating your model, you can identify its strengths and weaknesses and then fine-tune it for better performance. Evaluating machine learning models is essential for making informed decisions based on data. Whether it's predicting customer behavior, detecting fraud, or diagnosing diseases, accurate model evaluation is paramount. Effective model evaluation helps us understand if our model is truly learning or simply memorizing the training data. This distinction is crucial for building models that can generalize well to unseen data and provide reliable predictions in real-world scenarios. Understanding the different evaluation metrics and how they relate to each other is key to building effective machine learning models. This essay will guide you through some of the most important metrics and how to use them to assess your model's performance. The confusion matrix, a foundational tool. Before diving into specific metrics, let's introduce the confusion matrix. Imagine a 2x2 grid. This is your confusion matrix. True positives. The model correctly predicted the positive class. True negatives. The model correctly predicted the negative class. False positives. The model incorrectly predicted the positive class. False negatives. The model incorrectly predicted the negative class. The confusion matrix provides a clear picture of where your model is making correct and incorrect predictions. Accuracy, a simple metric with limitations. Accuracy is the most intuitive metric. It simply tells you what percentage of predictions were correct. It's calculated by dividing the number of correct predictions, true positives plus true negatives, by the total number of predictions. High accuracy means the model is making correct predictions most of the time. Low accuracy means the model is making incorrect predictions frequently. While easy to understand, accuracy can be misleading, especially with imbalanced data sets. Imagine a data set where 95% of the data belongs to one class, like non-spam emails. A model that always predicts non-spam would achieve 95% accuracy, even though it's not actually learning anything useful. In such cases, relying solely on accuracy can give you a false sense of confidence in your model's performance. Accuracy is a good starting point for evaluating your model, but it's crucial to consider other metrics, especially when dealing with imbalanced data sets. To get a more comprehensive understanding of your model's performance, we need to delve deeper into other metrics like precision and recall. Precision and recall navigating imbalanced datasets. Precision and recall are crucial for imbalanced datasets where classes are not equally represented. Precision answers. Of all positive predictions, how many were correct? High precision means few false positives. This is vital in medical diagnosis. Recall answers. Of all actual positives, how many were identified? High recall means identifying most positive cases, important in fraud detection. Precision and recall often have an inverse relationship. Increasing precision might decrease recall and vice versa. The balance depends on the problem you're solving. The F1 score is a single metric that combines both precision and recall. It's the harmonic mean of precision and recall, providing a balanced measure of the model's performance. A high F1 score indicates that the model has a good balance between precision and recall. On the other hand, a low F1 score suggests that the model is either sacrificing precision for recall or vice versa. The F1 score is particularly useful when you need to find a balance between precision and recall. It's often used in information retrieval and binary classification problems where both false positives and false negatives are important to consider. For example, in a news article classification system, you want to ensure that articles are classified into the correct categories while minimizing misclassifications. The F1 score provides a single metric that reflects both the accuracy and completeness of your model's predictions. By considering the F1 score, you can select models that perform well on both precision and recall, rather than optimizing for one at the expense of the other. While accuracy, precision, recall, and the F1 score provide valuable insights into your model's performance, it's essential to remember that they are just metrics. They don't tell the whole story. It's crucial to consider the context of your problem. the specific goals you're trying to achieve, and the potential consequences of different types of errors. For instance, in a medical diagnosis system, a false negative, failing to diagnose a disease, could have far more severe consequences than a false positive, which is incorrectly diagnosing a disease. Therefore, you would prioritize recall over precision in this scenario, even if it means accepting a higher rate of false positives. Understanding the limitations of each metric and the trade-offs involved is crucial for making informed decisions about your model. Evaluating machine learning models is not a one-size-fits-all process. It requires a holistic approach that considers multiple metrics, the specific problem domain, and the potential consequences of different types of errors. By analyzing the confusion matrix, you can get a detailed understanding of where your model is making mistakes. Accuracy provides a general idea of how well your model is performing, but it should not be the sole metric, especially with imbalanced datasets. Precision and recall offer valuable insights into your model's performance when dealing with imbalanced datasets, and the F1 score provides a balanced measure of both metrics. Remember that no single metric is perfect, and the best approach is to use a combination of metrics that align with your specific goals and the context of your problem. Real-world applications of model evaluation principles are vast and varied. Here are a few examples. In healthcare, high recall is crucial in disease diagnosis to ensure that most patients with the disease are correctly identified, even if it means some healthy individuals are falsely diagnosed, resulting in higher false positives. In finance, fraud detection systems prioritize recall to minimize the number of fraudulent transactions going unnoticed, even if it leads to some legitimate transactions being flagged, again resulting in higher false positives. In marketing, recommender systems focus on precision to ensure that the recommended products are relevant to the user, even if it means missing out on some potentially interesting recommendations, leading to lower recall. By understanding the nuances of each metric and how they apply to different real-world scenarios, you can make informed decisions about model selection, optimization, and deployment. Choosing the right metrics for model evaluation is crucial for making informed decisions about your model. There is no one-size-fits-all approach, and the best metrics to use depend on the specific problem you are trying to solve. For instance, if you are building a spam detection model, you might prioritize precision to avoid classifying important emails as spam. However, if you are building a fraud detection model, you might prioritize recall to minimize the number of fraudulent transactions slipping through the cracks. It's essential to consider the potential consequences of different types of errors and choose metrics that align with your overall goals. By carefully considering the context of your problem, you can select the most appropriate metrics to evaluate your model and make informed decisions about its deployment. Mastering model evaluation is crucial for anyone working with machine learning. By understanding the key metrics, their strengths and limitations, and how they relate to each other, you can gain valuable insights into your model's performance and make informed decisions. Remember that model evaluation is an iterative process. It's not something you do just once at the end of your project. By continuously evaluating your model throughout the development process, you can identify areas for improvement, fine-tune your model, and ensure that it meets your specific requirements. As you delve deeper into the world of machine learning, you will encounter more advanced evaluation techniques and metrics. However, the fundamental principles discussed in this essay will provide a solid foundation for understanding and evaluating your models effectively. By embracing a holistic approach to model evaluation, you can build robust, reliable, and impactful machine learning models that drive meaningful results. This essay provides a starting point for understanding model evaluation. To further enhance your knowledge, consider exploring these areas: ROC and AUC curves, visualizing model performance across different thresholds; cross-validation, evaluating model performance on unseen data; hyperparameter tuning, optimizing model parameters for better performance. By continuously learning and experimenting, you can become proficient in model evaluation and build high-performing machine learning models that address real-world challenges.